Hello everyone, Radu here from Infinet Wireless. Thank you very much for joining me today. As you can see, this time around the webinar will be a bit different. I have here with me a few Infinet radio devices, and I will show you all the options that you have for installing them, powering them, grounding them, and protecting them against lightning strikes. The idea is for you to understand how flexible our solutions are, and that we can basically cover every situation that you might encounter in the field. In some situations, you might not have AC power, for example, or you have to use batteries or solar panels, or you might not have a pole to install your antennas and you must install them on building walls, for example. You will see that we have you covered for all these situations. As usual, in the end, we will have a Q&A session. So if you have any questions during the webinar, please write them down in the chat section. And my colleague Bogdan is also here to help me today. Right, so we can get started. I want to start with a short overview on how to connect the main components. The Infinet Wireless radio systems are comprised of two main components: an outdoor unit called ODU, which is the main radio device, and an indoor unit, the IDU, which is the power supply for the radio device. The radio device can have either an integrated or an external antenna. As their name suggests, the outdoor device can be installed outdoors. It has ingress protection from water, dust, and so on. And the indoor unit, the power supply unit, can be installed only indoors in shelters. It doesn't have any ingress protection. Now, the cable between the two units must be an FTP Cat5e outdoor cable. It's obviously not included in the package because it differs in length from one installation to another. It can have tens of meters. The main specifications for the cable: the length must not exceed 100 meters, and the diameter must not exceed 7 millimeters. Right, so the cable is not included, but the connectors, however, are included in the package, and it's very important that they are different. So we have a shielded connector and an unshielded one, and the shielded connector must go inside the IDU. Shielded RJ45. Right. So this is very important because it helps both grounding and lightning protection, and you must remember that the shielded RJ45 goes inside the IDU. To the IDU, the AC or DC power is also connected, and the local network as well. So the cable between the IDU and the ODU will carry both data and power. Both devices must be grounded, but first the ODUs. And the IDU, only in case you use DC power, you must ground it separately. When you use AC, the grounding is done via the 3-port cable and the grounded socket. Now we will move on to the table, the installation instructions. And you can see here that I have prepared 3 types of Infinet devices, because we have 3 major hardware revisions in our lineup. So first we have an XG, which is a hardware revision 12. Then we have an SMN light unit, an Infilink 2x2 light unit, which uses hardware 11. And finally, an hardware 08 device, an MMXB base station. I have chosen these 3 units, so one from each hardware revision, because each hardware revision uses different power supplies, and the mounting kits can be slightly different as well. Okay, so moving on to the cable First, this is what I want to show you, the outdoor cable that I also mentioned earlier. And it must be an outdoor cable, so it's usually black. It must have UV protection, so the jacket is not damaged by the solar radiation. And more importantly, it must have metal shielding and a drain wire, because these help grounding and lightning protection. Basically, they help direct the unwanted electrical noise from the cable or surges towards the ground via the IDU. So here you can see that I have already crimped this connector, and I have left a bit of shielding and drain wire exposed, so you can see them. In real installations you must cut these off, but now I have left them for you to see them, and to insist on the fact that the shielding and the drain wire must make good contact with the shielded connector. This is very important. Okay, so at the other end we have the connector that will go inside the ODU. This is a regular simple RJ45 connector, plastic with no shielding. The cable is a straight through cable, so the pinout is identical at both ends, and the wiring is done according to the T568B color code. The connector from the ODU side also has a protective rubber jacket, because it's installed outdoors and it's for extra protection. But the main component that secures the cable on the ODU is this cable gland over here. You must remember to put the gland on the cable before you crimp the connector. It has two main components: a cable gland nut and threaded coupling. This is the gland for the XG, and the power cable, when you power an XG unit, must go into the gigabit Ethernet 0 port. It's very important. No power goes through the gigabit Ethernet 1. About the cable glands, I want to show you the glands for the other types of devices as well, because the glands are different from one hardware revision to another. I will unfasten this, and you will see that it has three components: the nut, sealing grommet, and the threaded coupling. So you just connect these like this and fasten them on the unit. Very, very simple to install. And the base station, the hardware 08 device over here, has a third type of cable gland, and the main difference is that now the connector fits perfectly inside the gland, and the rubber jacket is no longer needed. So yeah, this is the main difference from the other types of cable glands. Now I want to go back to the XG, and I will show you how to properly ground it. So first, about grounding, I must say that every Infinet ODU has a grounding port, like you see here on the H11 unit. The port comes with a grounding connector, a ring connector, so you just have to take the connector and put it on a cable. You don't have to provide your own connector, just the grounding cable. I have already prepared a cable over here, so I have crimped it, and I have used a heat shrink tube as well. This is very important to protect the connection between the cable and the connector. The grounding cable must be at least 2.5 square millimeters, and now I will show you how to install it on the unit. You just unfasten this screw here from the grounding port, then put the cable and fasten it. And to securely fasten it, you use a 10 millimeter wrench. Right, so now I want to move on to the different power supply units that we have for our devices. So first I must say that as standard, all our devices come with AC to DC power adapters. So the XG here comes with an IDU BSG 60 watts. This is the power supply for the XG. It's as the name suggests, it can output a maximum power of 60 watts. It's the biggest power supply we have in our product lineup, and it supports gigabit Ethernet. Then for the H11 devices, the standard power supply is this one over here. It's called the IDU CPE. It can output 24 watts maximum, and it is limited to fast Ethernet speeds, and it cannot be used to power any of the bigger devices like the XGs or the Pro units and the base stations. And finally, for the 808 units, we have the IDU BSG over here. This can output 50 watts maximum. It supports gigabit Ethernet, and it can be used to power H11 as well. It cannot be used for the XG because it cannot provide enough power. Okay, so all these three power supply units are AC to DC, but as we know, in many situations there are sites where you don't have AC, you only have DC power. So we also provide solutions for these situations as well. And we have two DC to DC injectors in our product range. And the first one that I want to show you is this one over here. It's called the IDU LAG. It's used to power the H08 and H12 devices. As you can see, it's closed now, but in order to access the ports, you must open it by unfastening these two screws over here, which I have already done. So yeah, then you can look inside the unit at the ports. So you can see that there are two Ethernet ports, one for the ODU and one for the local network. A DC port, a special DC port that uses a special cable that comes included with the DC power supply unit, and a grounding port as well, to which I have connected a grounding cable, because with the DC power supply units you have to make the grounding yourself as compared to the AC to DC adapters. The specifications for this device are input voltage between plus minus 43 and plus minus 56 volts, and the output voltage is the same as the input. It can be used to power H08 and H12 devices, and in some situations it can be used for H11 as well, but only when the input voltage is positive between plus 9 and plus 56 volts. If you power H11 with this one and minus 48 volts, for example, you will damage the unit, so please keep this in mind. Okay, so obviously it supports gigabit Ethernet because it's used for H08 and H12. And now I will demonstrate how to power a unit using this DC adapter. As a DC power supply, I have here 4 12 volts batteries, which I have connected in series to get a 48 volt power supply. And these are small batteries for lab use, so I don't recommend using these kind of batteries in the field, because obviously there you will need the unit to run for a long time and you will need much bigger batteries than these. Okay, so now I will connect the two terminals to the battery, and then you will see that the H08 unit will start up. It will take a few seconds for the unit to boot, and then you will see here the green LED flashing in a few moments that will indicate that the RF interface is up and the unit is searching for other devices to establish links. Yeah, so now you can see the LED flashing. The unit is powered on. Okay, so I will disconnect it now. And as I mentioned earlier, the H11 devices cannot be powered by the IDU LAG in all situations. So obviously we have a second DC injector especially made for the H11 devices. It's called the IDU CPE DC, and as the name suggests, is the DC version of the IDU CPE that I showed you earlier. Right, so the input voltage for this device is between plus minus 36 and plus minus 72 volts. So it minus 48 can be used to power the H11 in this case with this device. The output voltage is fixed at plus 48 volts, and it has this plug-in connector here that you can use to easily attach the cables from the DC terminals and the grounding cable as well. And now I will use this to power the H11 unit as well. Again, the unit is connected, and all I have to do is to connect the battery terminals. Right, so the unit has started, the power LED is on, and in a few seconds you will see the RF LED flashing as well, indicating that the RF interface is up and the unit is searching for peers, for other devices to establish links. Yeah, so you can see the RF LED flashing. Perfect, so now I can disconnect the batteries. All these power supply units that I have presented until now are IDUs, so all of these cannot be installed outdoors. They don't have any type of ingress protection, but there are situations when you might need to install the power supply unit outdoors because you simply don't have a shelter or somewhere inside to install it, like on a mountaintop, for example. For these situations, we have a special product. I have it here. It's called the auxiliary ODU INJG, yeah, I will show you how it looks in a few moments, but first I will draw a schematic to show you exactly what is different from the first case. Right, so again we have the two blocks, but this time they are both ODUs. Both units can be installed outdoors, both the radio and the power supply unit. The radio has the same antenna. The cable between them is the same FTP Cat5e with the shielded connector here. Shielded RJ45. And another important thing, this type of device is also a lightning protector as well, so it has superior lightning protection to the regular IDUs. I will go into more details about this in a few minutes. The auxiliary ODU INJG can be powered only with DC power. So yeah, in most cases, if you need to install it outdoor, you don't have AC power at all, so DC is just fine for this type of device, and the local network as well here. And of course, these must be properly grounded as well, both the radio and the power supply. Right, so now I will go back to the table and show you how this injector looks. Right, so when you open the box, first you will find a quick start guide with useful instructions, and then this is the unit itself. It has 3 ports. I hope you can see them. So you have an Ethernet in, Ethernet out, and the power port. and also a grounding port as well. Okay, so I will show you the power port right here. I hope you can see it. And in there you have this special plug-in port here that is included in the package, which you can use to easily attach the cables from the DC terminals over here in this, and then just plug in the connector in there. Besides this, you also have the two shielded and unshielded connectors for the FTP cable. And of course you have some clamps, some hose clamps that you can use to attach the injector to a pole, and some cable glands. Right, so I have to put the instructions inside as well. I'll put this aside. So all our IDUs by default have built-in lightning protection via the grounding and the shielding of the cable and the shielded connector. All these, if they are correctly installed, help direct the surges, as I said earlier, the surges and the unwanted electrical noise to the ground. But this does not guarantee that your power supply and your radio device will not be damaged in case of powerful lightning strike. In these cases, you must use additional protectors, lightning protectors, in between the IDU and the ODU. That's the only way you can be fully protected when you want both your power supply and your radio unit to be safe. So for these cases, we have this unit over here, the auxiliary ODU LPU-G, which is a simple lightning protector. It looks the same, it has the same case as the auxiliary ODU INJ-G that I showed you earlier, but this one cannot be used to power the ODU as well, the radio unit. It is used only for lightning protection. And yeah, I will show you now. I will draw another schematic and I will show you exactly how these lightning protectors must be connected. So again, we have the IDU, like in the first case, which is the power supply, the ODU here, radio, antenna. The IDU has the AC or DC power and the local network. And in between the IDU and the ODU, the power supply and the radio, these two lightning protectors must be installed. And in between all these, we will have the same FTP Cat5e cable that we saw earlier. These are obviously ODUs. They can be installed outdoors. And the shielded cables, again, similar to what we saw in the previous schematics, must be installed. The shielded connectors must be installed here, here, and here. So these are shielded RJ45s. All of these have to be properly grounded, of course. The IDU must be grounded as well, but you have to do it yourself, like I said earlier, only when you use DC power. And one more very important thing that I have to mention is that the lightning protectors have marked on them the ports as Ethernet in and Ethernet out. And it is very important for you to remember that the Ethernet out ports are the ones towards the unit that must be protected. So this over here is Ethernet out, and here as well we have Ethernet out. Okay, so obviously the Ethernet in ports will be these two in between the units. And yeah, so this is the basic schematic when you want to be fully protected against lightning. So these two lightning protectors must be installed as close as possible to the radio and the power supply unit. So the biggest chance is for the lightning to strike in between them, so the surge will not reach any of the important units. Instead of these two over here, in some situations you can use DC injector, for example. So these includes, as I mentioned, lightning protection as well. So you can use it here, but in that case, if a powerful lightning strikes this unit, it can be damaged. So yeah, again, this schematic is the only one that ensures you will have full protection for the power supply and radio. Okay, so now we will move on to the main mounting options that we have for our units, and I will start with the H11 unit, because this particular device here, the R5000 SMN or SMNC in 5 or 6 gigahertz with 19 dBi integrated antenna, this is the type of device that comes only with these clamps, these hose clamps included in the package. So I will show you. They are very easy to install. I will show you now on the pole how to do this. Right, so these can be fastened with a simple flat head screwdriver that I have here, or with a 7mm wrench as well. So you just fasten them and position the unit on the pole. As you can see, this type of mount does not allow you to tilt the unit, so you can move it up or down, left or right, but not tilt. You can't do tilt with this type of mount. But if you really need to tilt this type of unit, of course we have another mounting option, which I will show you right now. Take the unit back, and yeah, the mounting kit that I was talking about is this one here, the Mount Kit 85C. I hope you can see it. Yeah, this is the box, and inside it you will find what looks like a regular mount, which you will see in a few minutes, the Mount Kit 85. The main difference between one and that is this bracket over here that is specially made for this type of unit over here, and it goes on the bracket like this. It fits perfectly there, and then it is attached with the included hose clamps that you can see here. And besides that, you also have in this box a lever, a second bracket, and a bracer. And by using all these, you get a mount that allows you to tilt the unit as well. And it also allows you to install the unit on a bigger pole. So the standard clamps, these allow you to install devices on poles between 40 and 60 millimeters in diameter, and the bigger mount is designed for poles between 30 and 85 millimeters in diameter, like the 85 here as well, the mount kit 85. This is the standard mounting kit that comes with most our units, like H12, for example, the XG, H08, and so on, and with some H11 as well, the ones that have bigger antennas than 19 dBi in 5 and 6 gigahertz. And I have this 85 mounting kit, this mount kit 85 already prepared here, and you can see that the main difference between this and the C is the basement that goes on the unit, as I will show you in a few moments. And I must mention that there is a third mounting kit called mount kit 85S, and which I don't have here, but that is similar to this one. The only difference is that it's a bit bigger, a bit sturdier, because it's designed for the units with big integrated antennas, with 27, 28 dBi integrated antennas. Okay, so now I will show you how to put this mounting kit on an XG unit. First of all, on the back of the unit you will see 4 holes, and you must align the mounting kit over these holes, and then you just fasten it with these included bolts that you have in the package. I will move it a bit for you to see better. Okay, I'll put all these bolts in here. Normally in outdoor environments you must use anti-corrosion grease as well when fastening the mounting kit on the unit, but now in the lab I don't need it. And then using a 10 millimeter wrench you can secure the mount on the back of the unit. And after this, you take this bracer over here, and using the long 80 millimeter bolts, you attach it to the bracket of the mount. Yeah, and now we can take the unit towards the pole, and I will fasten it like this. Right, so after attaching it like this, you can use a 13 millimeter wrench to securely fasten the long bolts. And obviously this type of mount allows you to tilt the unit as well, so you can adjust height, azimuth, and tilt also. Okay, I will just secure it a bit more, and then I will bring the cable, the included cable. So after installing the unit, you must connect the cable, and yeah, you must put it in the gigabit Ethernet port as I showed you earlier. Then secure the cable gland. And now the cable, the remaining cable, must be secured to the pole using cable ties, and a loop must be left here for water drip, and also for future extensions if you want to move the device to some place else. I can take the unit off because it's no longer needed here. Okay, so I want to mention a few other things regarding lightning protection. When you have poles with no special lightning protectors like I have here, it is recommended to install the devices at least 1 meter lower from the top of the pole because there is a good chance that the lightning will strike the pole and not the ODU or the antenna. The pole must be properly grounded to the grounding circuit of the building according to your local regulations. When you use devices with external antennas, if the antenna is not DC shorted properly, you must use special lightning arresters on the RF cables between the external antenna and the device itself. Right, so this brings us to the end of the video. Now I will quickly go to my PC and answer your questions. Right guys, so I'm back. The first question that I see here is does IDU-LA support regulator? I have to ask my colleagues for more details about this, but normally from what I know, a regulator just ensures a constant output voltage. So if the voltage is constant and is in the range of what our devices support, then no problem, you can power them. So it should work. The next question, can we power an LMN unit using IDU-LA with 48 volt rectifier? I think yes, yeah, as long as your device, your rectifier and IDU-LA can output a positive voltage between +9 and +56 volts, no problem, this setup should work. Now I must mention that regarding all these specifications for our power supplies, you can find a very useful document on our IW Academy. You can find it on our website on infinitewireless.com, and from there you can go to IW Academy, and in the documents section you will find a very useful application note called Powering Infinet Units, and there you will find all kinds of information and all the specifications and compatibility matrix between all our power supply units and radio devices. Right, so another question about solar panels. Yeah, so as long as they output the necessary voltage for each unit, you can use them, no problem, instead of the batteries. Actually, it's a very good solution for remote areas where you cannot take big batteries and leave them there. Solar power is a really good option in this case. Next question, can you give us a small brief about the problems that the Infinet equipment can face due to the lack of an earthing or grounding system? So a hardware problem would be damaging the Ethernet port, and in operation, obviously if you don't have the Ethernet port anymore, the system will not work. But when you have other problems like electrical fields that can affect the cable which is not properly grounded, in these situations you can have some data loss as well. Grounding is really important, so please perform it every time you use the Infinet devices. Right, so next question. If you do not have a proper grounding point, would you still advise to ground the radio? Yes, of course, yeah, it's in all situations it's advisable to perform grounding. Next question, hardware failure can be also attributed to a power surge? Of course, yes. So the IDU can handle some types of surges, but if the surges are very, very powerful, like in case of lightnings, for example, the IDUs can be damaged. Next question, does Infinet Lightning Protector support Cat6e FTP? Yes, if the connector is the same as for the Cat5e cable, yes, you can use Cat6 FTP as well. We have another question. Yeah, how can we provide earthing for an IDU with AC? So as I mentioned during the webinar, the grounding for an IDU with AC is done via the power socket, the grounded power socket. So the unit itself, the power supply unit, has a power cable with 3 connectors, and one of them is used for grounding. So the socket must be grounded. That's how it's done in this case. Right, so thank you very much again, and see you next time.